Hi and welcome to this video on calculating areas, maths made easy. In an exam we can be asked the areas of a square, rectangle, triangle, parallelogram, etc. And there's no two ways about it, you just got to know these formulas or how to work the formulas out. So for a square with this length w, the area is w multiplied by w, which is w squared. For a rectangle, w multiplied by L, so each of the length multiplied by the width. For a triangle, half the base multiplied by the vertical height. For a parallelogram, the base multiplied by the vertical height. For a circle, pi r squared. For a sector, theta divided by 360, which gives us the fraction of the circle, multiplied by pi r squared. For a trapezium, a half, AB, which are the two sides which are parallel to each other, half A plus B multiplied by the vertical height. And for a rhombus, half the diagonals multiplied together, so a half A multiplied by B. When we're talking about circles, let's just go over some of the terminology. So from the center of the circle to the circumference, that's the radius. The line that splits the circle into two and goes through the center of the circle, that's the diameter. The area of the circle is given by pi r squared, where pi is 3.14. The circumference of the circle is 2 pi r, so that's this line all the way round, or 2 times the radius is the diameter, so the circumference is also pi times the diameter, pi d. So 2 pi r or pi d. So here in this example we're given the circumference as 5 centimeters. So 2 times pi, which is 3.14, times the radius, which is 5, and the answer is 31.4 centimeters. Calculating the sector, so here we've got a sector within a circle, this angle theta. So the area of the sector is the fraction of the circle, which is theta divided by 360, which is the number of degrees in a circle, multiplied by the area of the circle. So that's the area of the sector. The arc length, which is this here, the outline in dark of the sector, the arc length is given by the fraction of the total, which is theta divided by 360 multiplied by the circumference. If we want to know or want to find the area of this segment, so we have a chord and the area between the chord and this part of the circumference, or this arc of the circle, is the segment. Then we draw a triangle as such, and then find the area of the triangle and subtract it from the area of the sector. The area of the triangle is given by these two, the half the base multiplied by the height. The whole of the base is given by 2 times r sine theta over 2. So if we have in our trig diagram, this angle here is theta divided by 2 because we've bisected it here. So theta divided by 2, this is our 90 degrees, this is our r, and we want to work out this as half the base. So the full base would be 2r sine theta divided by 2. The height, which is this along here, which is this dotted line, would be given by r cos theta divided by 2. So to find the area of the triangle, we just multiply r sine theta over 2, which is half the base, multiplied by r cos theta divided by 2. Area of a triangle, half the base multiplied by the height, or half AB sine theta. The perimeter is given by these lengths added together, so 3 lengths A, B, C added together gives us the perimeter. Here we've just done some calculations to show how we find the area. So half the base, which is 9 times 8, multiplied by the vertical height. So we can have 9 multiplied by the vertical height, 8 divided by 2. So that's half the base times the height. Again, half the base multiplied by the height, 20 times 7 divided by 2. Half the base, so that's here we're dividing by 2, getting half. 6 times the vertical height, 4. 6 times 4 divided by 2, 12 centimeters is the area. Here we've got some more methods of working out areas. This is called Herons formula. It's good to know, but not essential, but good to know how to calculate it. Area of a square, S, which is this side, the length of this side, multiplied by S, which is the same length, so S squared, or S multiplied by S. The perimeter is given by S plus S plus S plus S, so this side plus this side plus this side plus this side, or 4S. Trapezoid, the area is given by half of A plus B, so we add A and B and then multiply by H and then half that. Half AB multiplied by the vertical height H. Perimeter is given by A plus B plus C plus D, the different lengths. Parallelogram. So these two sides are parallel to each other. Area is given by B, which is the length of the base multiplied by the vertical height. Perimeter is given by 2A plus 2B. So rhombus, the area is given by this diagonal and this diagonal, the lengths multiplied together, and then we half. So the length of P multiplied by the length of Q and half that. A rhombus is a special case of a parallelogram, and all the sides are equal. So is a rhombus a parallelogram? Yes, it is. Here we have a kite. In a kite, two pairs of consecutive non-congruent sides. So we have this side and this side. So these are non-congruent, so they're not the same. And this side aren't the same. However, these two sides are the same, and these two sides are the same. The diagonals between F and D and E and G are at right angles. So this line FD bisects line EG, so that means it divides it exactly into two at right angles. And also opposite non-vertex angles are congruent. So if we have this as a non-vertex angle and this as a non-vertex angle, then this angle and this angle are congruent. So angle at E and angle at G will be congruent. Also, these diagonals bisect the angle. So this diagonal bisects angle D, splits it into two equal parts. This line bisects angle E, splits it into two equal parts. Same here and same here. The area is the length of the two diagonals multiplied together. So FD multiplied by EG, the two lengths, and we half that. So length FD multiplied by length EG, halved. Sometimes it's good to know our special triangles to work out areas, especially if the triangle that we split the figure into is a triangle which is a 45, 45, 90 triangle, or a special triangle which is in this case 30, 60, 90. So in our 45, 45, 90 triangle using Pythagoras, the ratios of A, B, length B, and length C, we can use this ratio, which is x square root of 2. So if we want to work out the area of this square, we can do it quite easily by multiplying 20 by 20 and getting 400. But we can also split it into triangles. So this would be a 45, 90, 45 triangle. And our length here is given by 10. So we can have the ratio as 10, 10, 10 square root of 2. So this A, which we call the apothem, would be 10, and this, the hypotenuse of the triangle, would be 10 square root of 2. The area is given by a half AP, which A is the apothem, P is the perimeter. So the perimeter is given by 20 times 4, which is 80. So a half, 10 times 80, 400. In this case, we're asked to find the area of a hexagon. Again, we draw this triangle with the apothem, and the apothem goes from the center of the hexagon and bisects one of the sides. Here we would have 90 degrees. Draw a line from the center to the vertex, and we get a 30, 60, 90 triangle. So this is 90. This is our 60. This is our 30. So in a 30, 60, 90 triangle using Pythagoras, the ratios are x, and B is x square root of 3, and C is 2x. So using our side lengths and our length here of length A in our triangle with the apothem, we get 12 as that half the side, 12, half of 24. So the ratio of B would be 12 square root of 3, and C, which is this hypotenuse, would be 24. The area is given by half A, which is the apothem, multiplied by the perimeter. So A is 12, B is 12 square root of 3, and C is 24. So our apothem is actually 12 square root of 3, which in this case it's this length here, same as B. So this becomes 72 multiplied by 12 square root of 3 as the area. Here we've got a brain teaser, so stop the video and try and do these problems.